Welcome everybody to our Stages seminar. This week we have a guest speaker, Dr. Roya Narimani. She will be presenting a an introduction to artificial intelligence and machine learning techniques, as well as going over some things to consider for project feasibility assessment. Dr. Narimani got her bachelor's and master's degrees in natural resources engineering in Iran, and her PhD in water resources and coastal engineering in Korea before she came here to TAMUCC as a postdoctoral research assistant or associate at the Center for Water Supply Studies. Dr. Narimani is also currently an instructor in the Summer Big Data Blitz and the instructor for environmental forecasting in the fall. So any students that will be taking those classes over the summer and the fall, you'll be seeing a lot more of her. Her research interests and expertise also include hydrologic modeling, water resources modeling, and simulations, and all things artificial intelligence, which she will go over in more detail, also remote sensing and many other things. So without further ado, I'd like to invite Dr. Narimani to take over for her seminar.
Okay, good morning, everyone. As Audrey, Dr. Douglas introduced me, my name is Roya Narimani, and I'm a postdoctoral research associate and adjunct faculty here, working here at TAMUCC. And today I'm going to discuss a topic that is timely and significant before starting your project. So before we start, I want to give a quick overview about today's seminar. We will talk about the basics of artificial intelligence and machine learning and how to assess if possible, if project is possible, is feasible, right? So the goal is to understand how artificial intelligence can be actually applied and what factors to consider before starting any projects, right? So let's get started with the first slide. First, you need to know what is artificial intelligence. In informal conversations, the term AI is often used to describe machines or computers that mimic cognitive functions that humans associated with the human mind, such as learning and also problem solving. Also in computer science, AI is sometimes called machine intelligence, and it is intelligence demonstrated by actually by machines in contrast to the natural intelligence displayed by human. So AI is the ability of machines or software to act intelligently, and it is a field of study mainly focused on creating smart computers and programs, right? This is the meaning of artificial intelligence. Okay. Okay, I'm going to talk about key principles and techniques behind AI functioning first. So before that, let's take a look at the left side figure here. Can you see my cursor? And right? Okay. What is the difference between deep learning, machine learning, and artificial intelligence? Actually, deep learning is a subset here, subset of machine learning and artificial intelligence, right? And deep learning algorithms are neural networks that are modeled after the human brain, okay? So I mean that, for example, as you know, a human brain contains millions of interconnected neurons, right? To process the data and information, right? To give you an act, actually. And similarly, deep learning neural networks or artificial neural networks are made of many layers of artificial neurons that work together inside the computer, okay? So artificial neurons are software modules we called it nodes, right? And which actually use some mathematical calculations to process data set we have. So artificial neural network are deep learning algorithm that uses these nodes to solve complex problems we have. Okay, look at the right side. Here you can see the neuron in the human brain, right? Which are related to the fundamental component of artificial neural network, right? These neurons, collaborate in a layers to process input data and generate output, right? So here, neurons are the basic building blocks of artificial neural networks, and they work together in a layer inside your computer and process the input data set to produce an output unit. Okay. Here you can see for deep learning techniques, we have 3 different layers. Input layers, which includes your data set. It doesn't matter, images, text, or Excel files, or whatever you have. This is all input set. And then we have hidden layer here. In this layer, you can see you have some mathematical calculation to just find some analyzing your data set in hidden layers. And then we have output layer, right? Okay. Let me go ahead. Okay. What is the benefits of artificial intelligence? The first one is automates repetitive tasks. What does that mean? It means that AI can handle boring, repetitive work, right? So people don't have to do it manually, okay? And the next one is extract actionable insights from large data set, which means that it finds useful information from big amount of data you have, and it can help you to make better choice, right? Okay. Also, it improves decision-making accuracy. What does that mean? It means that AI helps reduce mistakes and make smarter decisions, right? Okay, and it enhances user experiences. It makes, actually, it makes things more personal, like recommending you any movies which are based on your preference, right? This is all about benefits. Of course, we have another benefits for AI and machine learning, but this is only 4 of them, which is so obvious, right? Okay. Okay. Actually, in many projects, assessing feasibility involves multiple factors, right? Like finding a data set or defining objective and evaluating methodologies and considering resource constraints, right? Here you can see different types of data set we have. The first one is hydrological data, environmental data, geospatial data, biological data, right? Social science data. These are just actually few examples here. And there are many other types of data sets available, actually depending on your specific area of interest or research, right? This is just simple, different types of data sets we have, right? Okay, this is the first step, your data set. You need to know the difference between all data sets you have. Okay. As you know, we have various sources of data set that are freely available for download, including some websites, repositories we have. And here you can see some websites and repositories we have to download your data set freely, right? When you start a project, you may want to use two different types of data, like primary data set and secondary data sets, right? Primary data set is those data set that you collect yourself or as a team, right? But secondary data set are those you are downloading from some websites, right? Like some images, some satellite images, radar images, or other types of data set you want. Okay. Okay, let's assume that you have your data set ready to use for the project you have. Okay, then what is the next step? The initial and crucial step is pre-processing your data set, right? In terms of, you need to actually address noisy values, missing values you have, or imbalanced data set, or duplicate data you have, right? This is a kind of pre-processing data set. So after that, the next step is data mining, right? For data mining, actually, you may need to focus on discovering any patterns and knowledge from large data sets you have, right? This is data mining. I will talk about this more in the next slides I have. And after that, okay, you pre-processed your data set and you want to select the best model for your project, right? The first one, after that pre-processing data set and data mining, you need to know the different types of data set you have. We have categorical data set, we have numerical data set, right? So which one do you need? Which model are based on this type of data set you can use? So following data mining, we can run the model and experiment with various models based on the problem at hand we have, right? So I mean, we pre-process and analyze the data set to uncover complex relationships, right? Making them ready for input into your model. Okay, then you can run the model. All right. Okay. Okay, after you run your model, what is the challenges you have? Actually, we face some challenges when we selecting the suitable model, which we need to address them carefully, right? The first one is data quality and quantity. Insufficient data, noisy data, imbalanced data. Many models require large data sets, okay, to perform well, right? So limited data can lead to overfitting and poor generalization. So inaccurate, incomplete, or inconsistent data can affect model performance, right? Be careful when you are using your model, okay? Which model, when you are using different types of data set, I mean. And the second one is feature selection and engineering. Actually, sometimes irrelevant features or factors can introduce noise and compliance, the model. The accuracy is decreasing. The accuracy of the model, I mean, is decreasing. So features in data set can sometimes have different units, right? Like some of your data set are in grams, or some of them are in millimeters or whatever, right? You should be careful for feature scaling. The other one is sometimes we need to reduce the number of data sets we have. because some of the data set have a good correlation together, like 99%, right? We called it multi-collinearity. I will talk about these kind of techniques in my class. So no worries at all. So we need to reduce those data sets, and then we can just fit the model we have, right? Okay. All right, model complexity, overfitting, underfitting. Some complex model can lead to, can learn the training data set too well, but when you want to test the model, it is not good for unseen data set and the performance is so poor, right? So this is overfitting. And also simpler model may fail to actually capture the underlying patterns we have in the data set and leading to low predictive accuracy, right? This is underfitting. We should be careful for those kind of challenges we have when we run the model. And another one, some advanced model we have, like deep learning, I already talked about it. So they are so difficult to interpret because we don't know what happened in the second layers, in hidden layers, right? We don't know what happened, but we call them black box models, right? So you should be careful when you are using any types of model. And also we have feature importance. So identifying which features impact predictions can be so difficult, especially in some complex models we have, right? Okay, and the next one is computational resources. You know, some of those models require significant computational power and memory, right? And making them impractical for large data set or some real-time applications we have. And also some of those complex model can take a long time, okay, to train the model. And especially when you have a large data set and you are working with big data, right? So it's just slow down the process, the development process, I mean, right? And we have evaluation metrics. Okay. Actually, selecting appropriate evaluation techniques is also important, right? Which aligns with business objectives can be so challenging, especially when you are dealing with imbalanced data sets, right? Okay, and also we have cross-validation. No worries at all. I will talk about all of these in my class, environmental forecasting. And actually properly validating model to ensure they generalize well to new data requires careful designs of cross-validation strategies, right? So you will, you need to know all these challenges you have when you run the model, okay? And, okay, other two challenges we have, you know, models sometimes can become less accurate over time, okay? Because of changes in underlying data, we have data distribution, I mean, and require regular update and retraining the model. So, okay, so integrating models into existing systems or workflows can be so complex and may require significant engineering efforts, right? And we have ethical considerations here. So it is so important to make sure that models don't reinforce or worsen existing biases in the training data to ensure the ethical use of artificial intelligence, right? Okay, and you need to actually protect sensitive data set we have, right? While you want to build effective models, it is so challenging to protect those sensitive data sets, right? Okay. All right, project feasibility assessment. It is so important to evaluate both the technical and optional feasibility of the proposed methodology and approach to just ensure that we have the necessary resources, expertise, and a realistic timeline for successful project execution, right? So the first one I said, technical feasibility. You need to have the answer of these questions before starting your project. Like, is the proposed methodology sufficient and practical for the project goals? And do we have access to the necessary data set, right? And are the modeling tools or any AI models or deep learning techniques you are using compatible with our computational resources or not, right? And operational feasibility, do we have the team expertise to implement and troubleshoot the models or not, right? And also, what are the time constraints? And is the project timeline realistic for model development, validation, evaluation, and stakeholder engagement, right? You need to know, and it might be so helpful to consider these questions before getting started, right? It is so important. All right. Okay. Here is a very simple example of one of my projects I did in South Korea, where I used machine learning to assess wetland health, right? And as you can see here, first I prepared the data set I need. And then I started with pre-processing and mining data set, like mosaicing, clipping them, normalization, and rescale them, resample them, all those images I have, right? And then I started making my model. And then after that, I need to evaluate the results of my model, right? This is a very simple example. Okay. Okay. And here is my current project, which I'm working on that in TAMUCC. And here we are using some water quality and groundwater level samples that were collected by students at TAMUCC for 3 counties. And I just added some data set, like some images from radar and satellite images to increase the number of my data set and enhance the model performance. So the selected, as you can see here, the selected model first trained, and I tested the model for our data set and also those ancillary data set I have. I downloaded. Okay. All right. Here is a simple flowchart that outlines all the necessary steps for you to follow before you want to begin building your model. Okay? All right. The first step here is data preparation or collecting your data set. I said before we have 2 different types of data. Of course, we have different types of data set, but this is just 2 simple categories of data. The first one is primary data. This is data you collect yourself. And also we have secondary data set. That is data you downloaded from some public websites, right? And also we have after preparing all the data set you need based on the problem, based on the output, based on the, it is so important to know which type of data set you need before starting your project, right? Okay, let's assume that you have your data ready. What is the next step? Data quality issues. The second step, you need to examine your data set for any noisy data, missing values. You may have some duplicate data, okay? And outliers, and also imbalanced data set we have. You need to look for all these kind of issues in your data set, right? And then once you identified, it is so important to pre-process your data set, as I mentioned before. So what does that mean? It means that you can complete your data set, you can fill in your missing values, and sometimes you need to remove outliers, remove duplicates, or transform outliers. Sometimes you have noisy data, you need to smooth your data set with other data set you have, right? This is so important, and you need to, like, you have different resolutions of images. I mean, spatial resolution and temporal resolution, you need to have them similar, right? So you need to resample your images to have all of them together similar, right? Okay, the next one, step 4, which focuses on data mining, right? Which is the process of, I said before, uncovering hidden patterns, trends, or relationships with the data. And you need to analyze. It started actually by analyzing summary statistics here and visualizing the data to gain a deeper understanding, right? Okay, this is data mining. Like, we want to first see the correlation between our data set. Okay, is it negative? Is it positive? Okay, is there any correlation between them? Can we use those data sets for model or not? So you need to remove them sometimes. So, okay, and the other one is like transform your data set. Sometimes you cannot find any correlation between your data set and you need to transform your data set, like log transform, like box Cox transform, or any types of transformation techniques we have, right? This is all about data mining. Okay, step 5 here. Okay, once your data set is pre-processed, it is time to select the appropriate model actually you need. A key consideration here is understanding the type of data set you have, as well as its size, okay? So the first part here is type of your data set. I already talked about this. We have 2 different data sets, like numerical and categorical. So if you have categorical data set, you need to use classification models, right? But if you have numerical data set, you need to use some regression-based model, right? Like logistic regression or other types of models we have. Sometimes you have time series data. So you can use long short-term memory, or you can use ARIMA for those data set, those type of data set we have. And the other important things is volume of the data, small data set or large data set, okay? So if you have small data, so use simpler models. You don't need to use complex models, right? Like those logistic regression, linear regression, right? You don't need to use AI techniques or whatever. You can use some statistical model, right? And sometimes you have large data sets, so you can use some complex models, right? Because in those, if you want to find some complex correlation between your data set based on the problem you have, you need to use complex models, right? Like deep learning models, I said, before, like random forest or some gradient boosting models we have, right? And sometimes in some cases, we are using different models and we have ensemble models which just contains different simple model, right? Okay, and we have temporal characteristics like time dependency, seasonality, and trend. Okay. What does that mean? You may want to ask some questions before using this type of like models you want. So do you have enough data set to detect seasonal patterns or not? So if you do not have any data set, you don't need to use it. You cannot use it, right? Those kind of models. And it is so essential to actually to assess if your data set are stationary or non-stationary, for example, because we have some models. What is the meaning of stationary data set? Actually, stationary data set, means that some statistical properties we have with your data set, it doesn't change over time, right? Those are non-stationary data sets. Okay, so with those non-stationary data sets, some of those models, like ARIMA, needs a stationary data set. If you put some non-stationary data set, you cannot get a good performance, right? So it is so important, and I think I forget to put that one. We have another one, nature of the problem, like we want to use supervised learning or unsupervised learning models, okay? So, which means that supervised learning models require labeled data set. Like we have some different data set and we just say, based on this data set, this area are vulnerable to flood, right? This is labeled, right? But sometimes you do not have labeled data set. So what you need to do, you need to use unsupervised learning models, like some clustering models we have, right? Like k-means or fuzzy c-means, like that. These are for clustering, supervised and unsupervised. Okay, finally, the last step is model building, okay? Depending on the nature of your data set and the problem at hand, you can choose from a variety of modeling approaches, including some statistical models, machine learning models, deep learning models, right? Okay. This is just a proposed workflow, and by following these important steps, you can effectively extract insights and build robust models and apply them to actually real world problems with confidence. Okay. Time is it? All right, that's time. And actually, to wrap up today's presentation, please note that you will begin with Big Data Blitz course in summer. And in that course, you will learn how to download your data set, how to pre-process them and make them ready, right? And also we have, you will be guided by some guest instructors there for just to find some best models, right, for your project. And also you will continue in my environmental forecasting class in fall, and you will learn how to develop your model, how to choose the best one. And I will guide you through the process, all the process you need from pre-processing until just building your model, okay? Okay, it's time for your questions. If you have any questions, I'm happy to answer. Thank you. Mm-hmm. Yeah. Mhm. Yes, that's a really good question. Actually, you know, sometimes you have, because we have some images like digital elevation model with high resolution, right? So for resampling our data set, most of the time we are using that digital elevation model, which we have it, I know for Australia, we have it in 3 meters. So it is really cool to use those when you want to resample other images like soil images, like land use, land cover images, but I would prefer high resolution, working with high resolution images. When you are using some models like CNN models, which you need to put those images in that model, it would be good to just use those kind of high resolution images. Yeah. Yes. Mhm. For clustering models, you want to use. Mhm. Yeah, actually, we have very uh, improved machine learning models, and I'm not sure how you can use those kind of models in for your project or not, but some classification models we have, you can use them. And also we have some, I think we have some clustering techniques like k-means, fuzzy c-means, or other types of clustering techniques. Did you try those before? No, you didn't, because okay. Uh-huh. You can start with those clustering techniques, and like k-means, like fuzzy c-means is the best one. Yeah, of course. Why not? Of course, you can. Yeah, you can answer. You can send me any email, and I would be happy to help you. Of course, why not? Yeah. Mhm. Okay. You have any other questions? Mhm. Mhm. Yeah. That's why yeah, thank you for your question. Actually, that's why I talked about some supervised learning models and unsupervised, because we are using those unsupervised, and you can search for that unsupervised learning models. Yeah. Mhm. Yeah, unsupervised, because those are good for just clustering techniques we have in that kind of models, because we do not have any labeled data set. So we need to use those models, not supervised model we have. And yeah, I suggest to use those unsupervised learning models. Supervised learning models, just you can use it when you have labeled data set. For example, you have groundwater elevation, and you can say that this amount of this value is high, right? You put a label on that. So, but sometimes we have some data set we do not have label, like we have different types of soil, different types of land use, but we don't know which one together can cause like flood, right? This is unlabeled, right? Unlabeled data set we have. So we need to use unsupervised learning. Yeah. This is, yeah, but with, I mean that, like, sometimes you just say, okay, soil is clay, and we have a high slope, and another one we have a high elevation. So the mix of these, you cannot exactly say it is flooded or not, right? Yeah, other factors, yeah, influence those data sets. Yeah. It's okay. Actually, I put this kind of feasibility, technical feasibility here, these kind of questions, and I just say you need to have the answer of these questions, because you need to know if your stakeholder have the enough data set to give you, or you need to actually download them from some website, because some of those sources are not really available. So you need to pay for them, right? And if you can just, find other types of data sets from just some sources that are freely available, you need to clearly talk about this kind of, because the first step, and it is very crucial to just have your enough data set before you start modeling, right? So, and I think I just put it here. Do we have access to the necessary data set, like those websites or other type of data? Sometimes you need high resolution and we cannot find it, Yes. Mhm. Yeah. Actually, when you start a project, it's better to have too many data sets, too much, because this is what I did. So you have, for example, I have some sampling data set and I put those in the model, and the performance was poor. So what I'm gonna do, I have to download some data set that are correlated with those sampling data I have, right? So it's better to first read some literature to see, like, those problems you have, the project, the title of your project, you have some papers published, right? So you can read those and to find which factors they are using, right? And you can download them, or you can ask the co-authors to give them to you if it is just, they are working on a similar study area or what else. So it is better to read research papers. So mhm. Yeah. Yeah. Let's assume that we want to make a flood vulnerability map. Okay. So I started with some data set like precipitation data. Okay. And I have a slope data set. I have digital elevation model. And then just say, okay, I have distance from each water bodies I have. So I'm just saying that, okay, these 4 factors are enough for now. So because they are all related, when I'm just analyzing the data set, those data mining I mentioned, you first need to analyze your data set to find any correlation between those data sets you have. When I found these kind of correlations, these kind of relationships with flood, so I can start modeling. But if I couldn't, if I have too many data, right, I'm working with large data set. So if I couldn't find anything, any correlation, and you need to sometimes transform your data set, like log transform, like Box-Cox transform, and other types of transformation techniques, okay, to find any correlations with the problem you have. If you couldn't find, it's better to just skip them, those data sets, and start with those that have a good correlation, right, with your problem. And you can start building your model. And then if you couldn't, if sometimes the performance is good, but is just, let's say it is acceptable, okay? And you can test your model. But sometimes if the performance is not acceptable, so you need to add more data set. And then you can find more data set, right? And fit your model, right? Yeah, 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 yeah. Mm-hmm. Yeah, yeah. Sometimes, yeah, of course. Sometimes I'm using some precipitation images, but there is no correlation with like flood, right? And when I just check them, so, okay, the other types of images is better than this one because it calibrated with those rain gauges, those observation data. So I would prefer to use those images, right? This is so important. So if you, for example, want to have some data for example, for precipitation, I would prefer to have like GPM, TRMM, all different types of images, satellite images or radar images we can use to see which one is better, right, for your problem. So it is so important. Okay, any other questions you have? Yes, of course. Sample. Yeah, yeah, of course, by all means. Yeah.
As of right now, there are only 4 placeholders on the calendar. I'm hoping to get at least.
You're welcome. What? Yeah, of course. This is started with my name. Dot. Yeah, that's here. Let me put it here. Yes. Yeah. Have a great day. Mm.
I'm just gonna leave on a seat, so I was just gonna come up here.
Oh my God.